Hello, welcome to this special tutorial. This is actually today's tutorial is outside of my broadcasting schedule. Reason why I'm doing this is because I have promised so many people to give a Git workshop, including the people who follow me on my Python tutorial every Sunday, and also my colleagues. That we have some colleagues that they are not devs, but they like but my teammates, like my colleagues, they're awesome, so they want to learn a little bit about Git, and hopefully we will have the whole company that we are all like very Git aware. And because I'll tell you why we love Git so much at the end, so please stay tuned. First of all, this slide deck is public now. I just made it public, and it's you can download it through the link at the top. So slides.com checkting_ho, that's my account, and then these slides is called what is Git. So you just type that in, and then you would be able to grab the slides. And also maybe I could also send it in the chat as well in a bit. What is Git? Let me give you a little bit of spoiler of what we're gonna cover today. Actually there will be two parts. So the first part is that I would give I will give a presentation of what is Git, and like what are the Git's operations and how Git actually stores stuff. Because I know that a lot of people they use Git, but they don't know actually how Git works. And so I just post the link of the slides there in the chat, so feel free to grab it. And so that's why I think is quite useful to understand a little bit about Git when you just get started. And the second part, we'll have a hands-on exercise that I would have a slide deck, another slide deck that you could follow and download Git and make your first pull request on GitHub. So I would try to go through the presentation first, and then at the time of the hands-on exercise, if you have already used Git, you don't need that, but you could ask me any questions. That will be a Q&A time as well. So okay, so let's get started. Let's start it by what is Git. So this is what I found in the official Git website. So it's Git scm.com. So scm means as what's that? Sorry, I just looked it up yesterday. I forgot. It just slipped my mind. It's like it's another term for the version control. So it's maybe source control. Yeah, things like that. So Git is the official definition. So Git is a free and open source. So that's very important. It's free, distributed version control system that is designed to handle everything from small to very large project with speed and efficiency. So okay, so there's quite a few questions here. So what is version control? So this is a term that I gotta speak a lot today, and so we better understand first what is a version control, and then you know why a Git could handle things that are from small and very large when we dive into how Git works. So first of all, version control, what it is, why you need it. The very easy way to think of it is like, have you ever make a copy of a file? It could be your your document or your spreadsheet, and then maybe you grab it from your colleague, from your friend, or maybe even you just like you have that file already there, and then before you make changes to it, you just make a copy because maybe I want to go back to this old version in the future. Well, it happens a lot when I was a student, when I was making homework, and or even like when I was looking for jobs, when I was making a CV. Well, I want to have different versions, right? Because like I may want to roll back to this one, and then make some different changes for a different job that I applied to. So yeah, but that's not the best way to do it, because what you happen to be having will be like a final version, or like a version 1, 2, 3, 4, and then it's a bit messy, because sometimes you put the date there, sometimes final version, but actually you make some more changes, so final version is not good. um, so the few benefits of using a version control system that help you to deal with all these things. First of all, you can time travel. So you could only have one file, and then you can go back to what it looks like before. So you don't have to make copy of the same file, having final version, final version, and all these things. The second is that you can collaborate with different people. So uh, for example, you may have this experience that my friend told me actually that they have these Google documents that Google documents you can share with someone else, and they could edit the file, and he sent it to the client, and the client makes some changes and accidentally deleted some of the important work. so so by using Git, something like Git or like version control system, that people can collaborate and work on the same file without changing it like together at the same time. So it's different from Google Docs. It's actually you all have a different copy in your machine or in your account. You make changes, and then at the end you just combine them together. So they kind of avoid a lot of accidents, because before you combine, you can check that, oh, actually you deleted those stuff, but you shouldn't be deleting it. So I would make some changes before combining them. So that's the better way to collaborate with people, because you won't necessarily mess with someone else's file. You can only combine them when you think it's safe to combine. And traceability. Also, you may heard about this term quite a lot if you have friends or if your colleagues they are devs, they will say like, oh, like just git blame, like what is git blame, like are we blaming somebody? Well, it's not necessary. It's like it just means that you can find who make that changes. So well, you can blame somebody if somebody make a nasty change, but but it just means that you could find who did what. And also because all the changes you will see later that is recorded, all the changes, you make a message of what you have changed in that change. So yeah, everything is recorded and traceable, so you can trace who did it and why they did it, because they will type it in the message hopefully. And so which is better if you are kind of managing things that could change all the time, like code, because softwares, they change all the time. You may have to fix a bug, or maybe you want to add some new features. So that's why it's designed for software development, but it's not limited to it. You need, if like I would tell you a little bit later when I cover GitHub, but you see that people use it, like especially devs, they use it in different things as well, which is kind of interesting. Anyway, um, okay, so how Git works. So if you have Git, and then if you make a so I think first of all I would like to talk about like you put things in a file, right? So or in a folder. So you have all this file that is in a folder. So for this folder, you can actually, when you have Git in your computer, you can make this folder a Git repo. So what is a Git repo? Git repo just means that it's a project. So inside Git, when you start making this folder a Git repo, so you just type. We can try it a little bit like at the end in the hands-on session, but you just type git init. So what git init, this command, what does this do? It's like it makes this folder a Git repo. So in a Git repo, there's a hidden file, a hidden folder actually. It's called .git. Usually you won't be able to see it because it starts with a dot. So any files or any folder that start with a dot is a hidden file or folder. You usually won't be able to see it, but in your command line, actually, let me see if I can show you a little bit about like whether I could. I can't have my terminal here, but yeah, actually, because I have so many things that I just like think of that it would be great to show you, but I hasn't think about it in advance. So this is just ad lib. So let me see if I can show you a little bit. And here, okay, now if I added the terminal back in, just bear with me in a second. It's like I said, this is ad hoc, and it's not necessarily there. Just 1 second. Yes. Right. Okay. Is it here? No, it's not here yet. That's very strange. Um, right. See if I can. Nope. Yeah, somehow like this doesn't work at the moment for some reason, and I don't know why. Hmm. Yeah, it should work in my. Oop. in my folder. I don't know why it doesn't work. Yeah, just want to show my terminal, man. Why it doesn't show? Okay, well, it doesn't work here now. So anyway, so what I want to show you is that actually this hidden folder, .git, that actually inside there is there's something that Git does for you to keep all your history of the changes of your file. So yeah, so inside this folder you'll see that there will be some blobs here. So this is the diagram that show you, like, for example, I have a folder that got 3 files. One is called readme, the other one rig file. So if you use JavaScript, you're kind of more more familiar with it. And also, oh no, sorry, not JavaScript, Ruby. And also you have another file, simple git.rb, and it's this file is actually in another folder called rib. Okay, so this may look like your project, right? So when you start a Git in this hidden .git folder, what Git will create it is to make, for each file, it will make a blob. So a blob is actually Git try to hash it. So Git is making you can think of it as an encoding. So Git make a copy of it, but in a more dense, compressed format. So it's called a blob. So all these blobs are created, and then Git also created some trees. So what are trees? Trees are actually a file that tell Git that what is inside. So the structure of your file. So you can see that because this simple git.rb is inside a folder called lib, so it's another tree. So inside lib, there's another tree that say that, oh, I have one file, and this file is represented as a blob. And in the root tree, there's like one level up. You see like different files have different blobs, and also I have this lib folder. So this is how Git remember all your files and how your files is structured. So by the way, fun fact, Git doesn't store things in diffs. So a lot of people think that Git store things in diff, but actually it doesn't. It just store all your files in this format called blob. So so you'll see later when we make some changes to the file. So this is when you type in it, you just started a project, you started a folder, and so Git is just like, okay, I'll make a copy and structure of everything and put it in my hidden folder. Okay. So when you make some changes to it, so by the way, you will know later the operation is that when I make some changes, I want to save it to Git. So I want to keep, when I want to, keep these changes to be recorded. So what I would do is I would do a Git Add. So we just tell Git that, okay, I have mixed these changes to this file. So keep a record. And then Git was like, okay. And then you type, okay, I'm ready for you to record it now. So you type git commit, and then you put in the message. You would do all this later in another in the second part. So so you type git commit, and then Git will so for example here, so I have this first commit. So this is, for example, when you started the project. So ignore this one. So the second one. So at the beginning we have one file that's called test.text, and then okay, I make some changes. I create a new file called new.txt, and I make some changes to this original text.txt as well. And maybe I add another line. I open it and make some changes to it. So this is okay, I'm ready to tell Git that, okay, save my work. So I would, like I said, git add and then git commit. So this is my second commit, and I'm and then I tell Git that, okay, it's fine. And then what Git will do is that Git will create this this commit. So everything is a commit. So this is the tree that I showed you before, right? And so everything, Git will create a commit, and it will create a new tree actually. So it create a new tree that I have a new file. So this actually will be having a new blob here, right? So this is, for example, this is the new blob that has a new file in a new.test. So tree, I've changed it. Version 1, I changed to version 2. So this is actually a new blob. So this is a different blob from the previous one. So actually Git doesn't store the diff. Git store what the state of your current file and the structure of your current file is. So this is the third commit. Ignore bug because this I grabbed this picture from the Pro Git book. You can see that here. There's the link. You can go to read all the details there, and I recommend you come back to do this experiment once you have done the second part of the tutorial. When you're when you have tried a little bit about Git, get a little bit more familiar, then you can come back to do this experiment in this web page. But I won't cover it now here because it's a bit complicated at this stage. And so this what okay, so ignore bark, and then you make another changes. This time you don't change the test or text, but so yeah, just ignore this third example because yeah, this is like more like when you do the experiment, this make more sense. But what I want to show you is that Git actually they have the commit, and each commit store the state of your file. So if your file doesn't change, actually it will like test or text, it just point to the same blob. But if you change it, it will create another blob to point to it. So this is how Git work under the hood. So if you so usually, like, unless you follow the experiment suggested by this link, usually don't mess with something in the .git because that's all your files and the history is stored. If you touch that, you will lose something that you don't want to. So yeah, that's where Git store all your stuff. Okay. So okay, so some terms that I want to maybe give you an idea before we try it. The There's very basic operations of Git. So there's branch and merge. So what is branch? Branch is just like, remember we have this tree, right? So you have all these commits. So for example, when I'm here, so what happened is that Git will have a head. So a head is just means that where you currently is. So for example, if I've made a third commit, and my head will be pointing to this third commit. So when I make a, let's say when I make a branch at this third commit, I would actually have two heads. So one head is for, let's say this is called a master branch. If I make another branch that is called maybe new feature, so actually there will be two heads. One head is the master and the other head is the new feature. So if I make some changes and make the fourth commit on the new feature, so the new feature head will be pointing to the fourth commit. And the fourth commit will be pointing to the third commit, pointing to the second commit. Just go back. But if master is still in the third commit, let's say I also make some changes in master and I push my change. This time it's master change, as the commit to it, and I'll have another thing called a master change that is pointing to the third commit and the second commit and the first commit. So it's like this picture. So for example, master keeps changing. Someone's working on the master, so it keep here. But if I make a branch at the first node here, I make a development branch. Then a development branch will be separate. So it's like a separate work that got saved. They all come from the same. At some points, they would be all come from the same commit, but it could be init, it could be the first commit, but it could also be like in the middle. For example, here you see that the feature branch, just coming from the development at different point of the development. So um, so merge is like this yellow branch that when I'm done with that feature, I'm happy to like I said, if because someone may be working on someone may be working on this blue feature, and let's say I work on this yellow feature. So it's a very simple feature. I branch it from develop, and take the most updated development, and then I make some changes. I added this feature. Okay, I'm happy with my work to combine. So like I said, you can collaborate. So your changes, you can combine them together by merging. And of course, you check whether things are okay. There's no bug. You're happy with it, and then you make a merge here at the yellow branch. But the whole process doesn't affect my colleague who is working on this blue branch. My colleague is still developing it, and then in the future, my colleague may merge it back to this development branch. And when the whole team is happy with the work, then we can merge this development branch to the master branch and release our work. So this is what branch and merge is. And Rebase. Rebase is very similar to merge, so some people just mix them up. But the difference between rebase and merge is that, so for example, at some point here, in this old base here, like you see I wish you can see my pointer, but I don't have a laser here or something. So so you see that we have this old base. This is when, let's say it's yesterday, right? So yesterday I branch out. I want to create this new feature. So I branch it out. I create it, and then but this time instead of merging back to the master of today. So this is today's master here with the last blue thing there. So instead of just merging it back, I think, well, I want to incorporate the changes from yesterday to today. So these two dots, blue dots in between the old base and the master, I want to incorporate them. So rather than I just merge it, I want to, as if I make this new feature today. So I do a rebase. So now my feature branch is actually branching from the master today. So this is the slight difference. A lot of time is almost the same as merge, but you will find cases that sometimes you want to specifically using one rather than the other. So usually here, if your change doesn't really interfere with the changes of these like blue master branch in between, you can do a rebase. So this is what usually happened. Right. And Cherrypick, this is a very is this a more advanced operation? I only do it once or twice in my life because this is very easy to make mistake, and it could get messy quite fast if you made a mistake. So what Cherrypick is like give you the full power. This is super powerful. It gives you the full power to take all your commits. So all these dots are the commits, right? Or the work that you save, or the changes that you save at different stages. You can just move it from one branch to the other. So what happened usually is that, for example, people make a hot fix. They want to, there's something, that they create some fix to the master. They just quickly put it back into the master. Or sometimes I remember why I did the cherry pick is that I think I accidentally make a commit to a branch that I don't want to make the commit to. I was supposed to make on this, like for example, I was supposed to make the commit to this green branch, but I accidentally make it to the blue branch. So I do a cherry pick and pick that commit out. Um, and it usually happen like you don't realize it after you have commit extra stuff on it, so you have to, so it's kind of in the middle, like this y thing here. It's kind of in the middle. I just pick it out and put it somewhere else. So you can see that Git is like fully flexible, and so usually it's quite safe. Like most of the time your mistake that you made with Git can be fixed. It could be a pain to fix it, but that's why Git is safe, because for example, like the example that I gave you before, if someone deletes something on the Google Docs, it deletes for everybody. It's so difficult to recover. But with Git, it's possible to recover, but it may be a pain to recover. But so that's why, like, I think as a beginner, some advice is like, don't worry about making mistake with Git. Everybody does. Everybody, when they started, they made a lot of mistakes, including me. I used to hate Git a lot because I made so many mistakes that every mistake is so difficult to fix, and I just, I spent an hour to fix a mistake that I accidentally made like within 1 second. But it's fine. It's the way to learn it. It's fixable, and by fixing it, you learn so much about Git that you will not make the same mistake again, and you will start to get the benefit of Git afterwards. So how about GitHub? So one thing that I know that a lot of people who are new to tech or new to software development will confuse about, because they sound so familiar, Git and GitHub. So GitHub, first of all, is not Git. They are not equivalent. They are not similar product. They're actually two different things. So um, one way to put it is that Git is actually, so the easiest way to think of it is that Git actually is happen in your local machine. So you could have, like I said, you have Git repo, which is your project. So you have multiple projects. For each project, you make some changes. So you make some branch to make changes. You combine them back together. It's kind of happening in your own sphere. so in some cases, you may have somebody who use Git to combine the work with your work, maybe because you're using the same computer, or there are different occasions. But usually in your own computer, you just use Git to combine your own work. GitHub provide a way for you to collaborate with someone else that uses a separate computer, maybe your colleague or your teammate, your friend. So we all put our work on GitHub, and so GitHub provide some extra operations that makes collaborating with people, even people that you don't know, easier. I will explain that afterwards. But GitHub provide, when you put some code on GitHub, you can also do the things like create a new branch, so people can have different branches and they can combine different branches. They could do that. But but GitHub is a service that sits in the internet. It's not in your machine. Git is something that you have in your machine. So now at this point, if you don't have a GitHub account yet, I would suggest you get one. There are other alternatives than GitHub. There is GitLab. You may have heard about that before. Bitbucket, you may also heard about that before. Those are the more popular ones now in the market. They are all like GitHub. They are servers that let people to collaborate on coding or on their Git repo online. So but I would I use GitHub. I like GitHub, so I would just use GitHub as an example here. And so I suggest you get a GitHub account. It's free. And so yeah, you just go to github.com and sign up. And if you want to switch your career or start your career as a developer, that's a must-have. Even if you try to do data science and other stuff as well, anything involving coding, it's good to have a GitHub account. Okay, so so on GitHub, you can have some extra operations. So what I gotta do is I gotta show you maybe a little bit of how GitHub looks like before I show you the operations. So let me go to my GitHub, and so yeah, if you have your GitHub, so this is quite busy because I use GitHub for quite a lot of things. It's quite busy at the moment. So maybe let's go to my yeah. So maybe go to one of my repo. I don't know which one should I show you. Maybe I would just show you my Terms client Python. So this is what I'm working at the moment for my work. So all of these is open. So you can have private repository, which is like a private project that only people you want access to have access. But if you work in open source, you want to, of course, open your code for people to see. So this is open. This is a public repository. And you'll see that this is the fork that I gotta talk about in a bit. So what it is, like this funny a fork. Are we eating here? And also you can see that pull request is also something that I want to talk about. There are a lot of features on GitHub as well. You can set up actions and all this. This is more advanced stuff that it involves CI/CD. Other operational stuff that I won't gonna cover today. Today is just Git for beginner. And so issues is just for people to report if there's something wrong with the code or suggestions. People can, so it's more like a place that developers hang out, and share their work and discuss their work and stuff. So it's quite cool. So yeah, I won't dive into detail. So I just want to show you that there's something called fork and pull request. So star is just like if you like that project, give them a star to give them, it's also bookmark in your thing as well. So you can see that I have all my stars here. So it's kind of like a bookmark, but also shows some recognition of that project. Watch as well. Watch is even busier than the star because you get notification if something changes to the project. So if it's a project that you really, really, really care about, then you can watch it. So yeah, so let's talk about what is a fork. So a fork is actually means that you make a copy of the repo and put it under your account. So for example, go back to my example here. So this one is under Terminus DB because it's a Python client, so originally it's under the organization of Terminus DB because it's a client for Terminus DB. So, but let's say if I am a contributor, I want to contribute, I want to add some changes to this Python client, then I need to make a fork of it. I think I can't do it now here because I already have a fork. So yeah, so let's say if I can't choose my own because I already have it, so I can't choose it here. So yeah, you can make a fork of of it. So what it means that for example, I click it again. So you see that I will have this. So after the fork, you will see something like here. So it's rather than under terminus DB, it's under my name. So this is a copy of the Python client under my account. So I make a copy. The reason of why you have to do this when you contribute on GitHub, why you contribute on an open source project, is that sometimes you don't know the person who maintained the project or who owns the project. Of course, I work in the Terminus DB team, so of course I know them. But if I, work, for example, I want to contribute to Bouquet, let's say, and I don't know the team of Bouquet that well, right? So they won't give me access directly to their repo. So what I can do is that if I want to make changes, I make a copy of that under my account. So because it's under my account, I have all the access to it. I can do whatever I like. I can even delete everything, but but it doesn't affect the original one because the original won't be affected. You can't delete the things in the original one, so it's safer for people to work on open source that way because you don't know the person who contribute to your project, so you won't grant them access until you have maybe that person work on your project quite a lot, you have built a relationship with them, you trust them, then maybe you can invite them to join your team to be the maintainer, then they can have access. So yeah, this is why fork is quite important in when you work on GitHub. So that doesn't exist when you work on your local computer. And sometimes, if, for example, if you are a software developer, maybe you don't contribute to open source, you only work with your team, then you may never use this fork feature because um, just you have access to all the projects that you care about in your company or in your team. So you don't necessarily need to do that, but that's quite a good feature of a GitHub. So the next thing that GitHub has is a PR. So PR is short for pull request that I showed you before. So pull request is just means that it's kind of like send a message to the owner of that repo. Hey, I've made these changes. If you like it, please accept it and combine my change to yours. So they can merge your work to theirs. Um, so it's also there's another term in open source that's called upstreaming, because the project that you fork it from is the upstream of your project. So putting your work back to that repo is called upstreaming. So um, so for example, I've made some changes and I can send a pull request to the Terminus DB repo, to the owner of that repo. It could be my boss. It could be someone who maintains it. Um, that you can create a pull request, and so what GitHub does is that when you create a pull request, you can choose which branch is your work sitting in. So first of all, you have to this is the your repo. So of course you choose your own repo. So don't choose other people's. So there's so many of them. I'm glad that we have so many contributors. So you choose your own, and then which branch is your work sitting in. So for example, I changed something in the devs, right? And I want to merge it back to master. I won't do it now, but yeah, and then you just say like, oh, this is where my work is, and please, once you started it, once you created it, then you will see that there's a page called a pull request. Actually, store all the information about your change, what has been changed, and or your commit message as well. So commit message is for you to explain what this work is about. Also, you can put all the explanation of why you make that change. Maybe you could link it to other issues because you fixed the problem that issue described. So yeah, it's like a message. But it's a massive message to the owner of of your upstream repo that okay, I've made this awesome work. Please take it and use it and love it. So yeah. So I think that's and then you already know a lot about all these how things work and got a good idea. So an overview of a workflow is that you have files. that you want to commit is like you make some changes. That's your work, the work that you have been, work on those files that you want to change. And you put them on the stage area. So here is a Git Add. So tell Git that, okay, this work, I've changed these files. Could you please make a record of it? So Git was like, okay, I'll put it here. So let me know when you're ready. And then, okay, I'm ready. So I tell Git, okay, Git commit, I'm ready. And I will give you a message. I've made these awesome changes. Okay, save it. So, okay, Git save it. And it's in your computer. So, okay, now you're ready. And then you was like, okay, it's so cool. I want to publish it. So you put it in GitHub. And then so you put it there. If it's your own repo, others can can pull it and use it. If it's not, then if you want to do upstreaming, send a pull request, and it's gonna be there forever, and people can use it, use your awesome work. So that's the kind of overview of the workflow. So I would like you to try now. So if you go to this link, it's a shortened link here, bit.ly /SPR. So this actually gives you a slide deck, another deck that I made ages ago that you could follow the steps. And I hope you already done the GitHub account thing, and I would suggest you work on this project. This is a sandbox project that let people to make the first request, to play around with, and install Git. So I think this is the thing that is like most important today. Um, so if you're using Linux, congratulations, you don't have to worry about it. It's included. Um, Mac, you have to install Xcode. So if you go to this link, it will show you like how to do it. In Windows, you have to download something called Git for Windows, and use it there. And after that, all the steps are step-by-step guides here. And I think there's one remarks I want to make. So yeah, this new branch just mean that you can make any name. In this bracket is you can't just put it as is because Git will complain you can't use these arrows in your name. But you can make up any names. You can put your name here or whatever. Um, so yeah, just try doing this. And yeah, again, this is the name that you made up before. Um, so yeah, once you've done it, let me know, and you can either let me know in the chat, or you have questions, ask me in the chat, and or um, if you have done it afterwards, put it in the in in my I have a box down there in my Twitch if you're watching now that you can let me know. And what is in a merge commit? Yes, there are no changes in it, right? It just bring magically the two branches together. Well, in a merge commit is means that so actually a merge commit. So usually what happen is that when you kind of okay you've done your work, and then you want to update. You have already made some changes, and your colleague makes some changes. You want to update your work, so you pull the work and do a merge. So so it's not magic. It's just like take all this work that your colleague did. So your colleague may make like 3 commits in between, right? So you take these 3 commits and then put all these changes into your work. So it's another commit because um, taking these changes in these commit and put it on your branch is another change. So that's the merge commit. And what is in it is actually, um, the remember the tree, right? That happens there. Let me go back to the slides. Oh. Yeah, so a merge commit is just means that if those blob doesn't happen, for example, let's say if it's on GitHub, you've so a pull. So when you do a pull, actually you do a fetch that grab all these blob and then do a merge. So the merge is actually pointing it back to those blob thingy. So if it doesn't happen in your machine, you first have to fetch it, and then when you do a merge, so it will connect it to those blob, those changes that your colleague made. I hope that kind of explained it. Um, yeah, yeah, it's kind of like magic. I know, like all the things that Git does is very magical. I think, like, yeah, you can even do this, right? You can even put one changes to another. It's like is magic. Um, so any other questions? I hope there is. Because otherwise, I just gotta sit here and listen to my classical music. I'm listening to some classical music in my headset. Because fun fact, my headset will turn itself off if I'm not playing something. So that's why I always listen to some music during streaming. But sometimes it's good, sometimes it's bad because it could really screw up my saying because sometimes the music too loud. Even I'm listening to classical music, some pieces are too loud. So I was like, no. But yeah. Any other questions? Any like funny story to share? Like I share my funny story of like um committing the work in a wrong branch and I didn't even realize it because otherwise if I realize it immediately I can undo it, right? And I can undo my work and then go to the new branch and commit it there. I forgot and then I commit some new things and I was like, oh my god, I need to pick that commit back out, so I have to do this um, tricky cherry pick thing to fix it. Um, so yeah, it took me quite a while, but and I learned cherry pick, which is good. Yeah, yeah. Share your story if you have any, and any questions. Because yeah, this tutorial I have. This is like I said, this is outside of my schedule, so I don't know whether like I haven't planned for how long it should be. I really want to show you the like those Git, Git experiment thingy. But I sorry, I hasn't prepared to show my terminal here, and somehow OBS doesn't like it. I can't edit there. Um, yeah. So I would maybe give a few more minutes if there's no more questions. I hope you really try that out. And the last thing, the last remark. Oh, actually, I will put the link in the chat in a bit, so don't worry. And I'll go back to the slides. But last things I want to shamelessly advertise is that because I work for Terminus DB, like I mentioned a few times before. So Terminus DB is actually Git for data. That's why all my colleagues and we love Git because Git is such a powerful concept, powerful tool, and the concept of version control is so powerful that um, it's actually uh, in data. If you are dealing with data, we need that as well. You can see like how powerful it is, right? You can roll back and all the changes will be recorded and you can collaborate with people without the scare of being deleted some of the stuff. And that's why I think it's a very cool feature that Terminus TB provided. And right now it's like Git, it's like locally you can do all this. You can create a graph, but in the future we have the hub for Terminus DB, so it's kind of like GitHub, that you could collaborate with your teammates, and it's super cool. So please check it out, and also thank you because obviously this is it's like 3 p.m. for me, so it's like work hour for me, and thank you for giving me the opportunity to do this tutorial that I want to do for so long. And I also give, like I said before, I also give Python tutorials every Sunday at 2 p.m. UK time. And also, I'm thinking about doing some new tutorials, like maybe something related to data science or something about testing. So follow me on Twitter for all the news. And if you don't want to miss any time that I go online, follow me on Twitch. You will get a notification. Make sure you turn that on. And so every time I have a tutorial, you can jump in, see if you like it, if that's the topic you want to learn, and you can decide to stay on or catch up later with the tutorial. But I recommend you to stay on, to stay in the chat because you can ask questions, like Jack Mac. Oh, sorry, like all your names are so difficult to pronounce. I think like because when you register for an account, you have to choose a unique name. But yeah, so thank you. I would really love to see people in the chat as well. But I think today I would just leave you with that exercise there. And lots of people have done it in my workshop before. I hope it's easy enough for you to follow. If you have any questions at any time, please feel free to find me on Twitter. Use the Q&A box below. I would, yeah, I would try to make more tutorials because this is what I like doing and I've been enjoying doing it. So thank you so much. I think that's it if there's no more questions. And thank you so much for watching. And I'll see you actually tomorrow. We will have Meet Me Pie, which is at lunchtime. We'll have interview with Tanya, a good friend of mine, also PS fellow and developer advocate of Microsoft. So yeah, I'll see you tomorrow. Bye.